Hi, my name is Barry. This is my Skit 2100 YouTube presentation, and today we'll be talking about the wave-particle duality of nature. To understand this, we'll first look at the classics of wave mechanics. This is quite intuitive. Say we have a pond here, we've created some ripples in our pond, they've hit my barrier with two holes in it, they transmit through the barrier as two waves. Where the wave peaks interfere with each other as they progress, we get areas of higher energy waves. And if we had some measure of recording the energy of the impact of the waves on our rear, we'd see a much higher distribution of the wave energy in some points. In our classical model of particle mechanics, we'll see we're firing a tennis ball here, for example, at the same type of barrier with two holes. Classically, our particle is going to go through one of the holes and impact on our rear wall with some deflection given for various physical constants, but basically we're going to have a result similar to the size of our hole. Now, where things get strange in the quantum world of particles, subatomic particles, atoms, neutrons, electrons, etc., is that they exhibit both these factors, both these characteristics. We fire an electron at our barrier with the two holes in it, and it will transmit through those barriers as a wave, typically as we would have seen with our wave in our pond. And we will again get high levels of impact of our electron wave on our screen at the back. Now, the strange part about this was scientists thought that firing an electron beam at the barrier was interfering, that many electrons were bouncing off each other. So they fired one at a time, and they found that this interference pattern still occurred. They fired 10,000 electrons over a period of time, one at a time, and we still had the same periods of high and low intensity across the thing, rather than just our classical straight through the hole results. Now, in order to see what exactly was going on, of course, scientists being curious, they put a measuring device on one of the holes to see what happened. Now, it got even stranger then. When they put a measuring device on that hole, they found that all the electrons went through that hole, and we ended up with a result similar to as if we were firing a tennis ball through our barrier. The mere fact of observing the electron through which hole it went meant that it actually went through that hole, that the wave nature of the electron collapsed and the electron became a classical type particle and hit the rear wall. This is the mystery, I guess you'd call it, of the wave-particle duality of light, or of matter. Once we observe it, it collapses into its classical state. Before we observe it, it is merely a wave, a probability, and that's what we're looking at with the wave-particle duality of matter. That it's a probability until observed, and then it collapses into its particles. Scientists have done this with carbon atoms, which you and I have made up. So questions arise eventually, or the mystery of quantum mechanics is, are we really here until we're observed? I hope this video was educational, and I look forward to seeing you again.